Hello and welcome back to Kerbal Space Programming, where we have put a Kerbal in orbit. You notice we're a little bit off axis here because I actually left this running and came back, and as soon as I came back the computer booted and started to abort, so I had to quickly turn that back off. Try and make this a seamless transition from the last episode. But yes, Valentina Kerman is in orbit, and we have a computer that is powered off, or at least it should be powered off. Yep. Good, and we're not draining any electric charge. Well, we've still got plenty, so that'll be great. And we've got just a little bit of fuel left. It's a very, very, very tiny amount, but it should be enough to deorbit us when we are ready to go down. So all the Valentina's going to have to do is hit this abort button. But before we do that, we are actually in orbit. Look at that. And what we want to do now is actually get out and do an EVA and get some science for great Kerbal glory. So Valentina, let's hop out of here. Okay, let's rearrange that camera, and let's let go. Turn on our RCS jetpack by hitting R. And there we go. Let's see, can we... Alright, well, let me turn the camera around. And look at the... Oh, you are excited. Let's do an EVA report and see what we see. We are above the grass lines, and we have recorded our observations about the situation. All business. Okay, so let's go ahead and get back in. We don't want to drift too far away from this thing because we do have a limited amount of EVA propellant. We've got plenty, but better safe than sorry. Let's go ahead and come on. All right, get on there and grab. All right, we can go ahead and board, and now we have saved that science. That is 8 science. And now it is just a matter of spinning and waiting around the planet to try and gather up just as much science as we possibly can. There's unfortunately not an easy way to tell when we've entered or exited a new biome, which means that the best we could do is kind of get out and check and try and do an EVA and then discard it if it was one that we already had. But the goal is really to get as much possible science as we could. And you'll notice, and I can't remember, the city lights DLL kind of shows lights on the dark side of Kerbal, and unfortunately I ended up running into some issues with that, where it started to turn the planet into a weird glitchy snow cone. So I actually removed that from the environmental enhancements mod. So if you're playing along and are playing with those mods, you might want to go ahead and look at removing that particular file just to try and make sure that your system runs well. But yeah, this ended up taking quite a bit longer than expected, so I guess I'm sort of talking over this in post-editing. I guess I should probably also mention that a couple of you suggested that I try actually live streaming, coming up with these scripts and kind of testing out the crafts, and so I tried that out last Monday from the day this video went up, and it seemed kind of fun, so I may continue doing that in the future, depending on, if people are interested, so, keep an eye out for that. And yeah, we just kept checking and checking. We had to keep repositioning the camera because when you go over the poles, Kerbal Space Program gets a little bit wonky about the physics there. And here you see I got particularly frustrated and just kept spamming and spamming and spamming, hoping we'd run over something, until I finally discovered that Valentina was getting dangerously far away from the ship, which was not great. And yeah, I think I was trying to see if we could get to the... Yep, there we go. So we had to make our way back and get back on that craft. So it's a little inefficient the way that this is structured, because we have this whole thing in orbit when really there's very little fuel left in that entire stage. But we finally managed to get, I think it was around here, I think we got Tundra or something, or... I don't know. I think at some point I just sort of gave up and said, okay, we've got all of the science that we are going to get on this trip, at which point we decided to fire abort, so back to real time. So now we have managed to collect, let's see, how many sciences do we have? We have 8 sciences. We can go ahead and, oh, no, I don't want to just, okay, keep all of those. Keep all those, don't delete them. Thank you. Okay. So now there's one more biome called the Badlands, but I'm not entirely sure where that is, and I think it's going to be hard for us to track that down. But that should be a whole bunch of science for us to bring back to Kerbal. So I think it is time for us to start our abort sequence. So we are going to boot the computer, and we wrote an abort script in the last episode, which it is going to fire automatically, and let's see how that goes. So here we go, we get that notice abort program initiated, and it notes that we are in orbit. So it goes, okay, I've got to figure out how to deorbit us with the fuel that we have left. So it's going to rotate us opposite of our current direction. And let's see, you gonna deorbit us, please? Please? Alrighty, so there we go. Now it says we've got orbital decay achieved, and it's gonna detach everything, including firing off this staging. So now this parachute is armed, and we've set the minimum pressure to relatively high, so we won't deploy too soon. We can take a look at the orbit that it achieved for us before we detached. We see that our periapsis is 29, so that should bring us down relatively steeply. And now the computer core was actually in this stage, so this will decay on its own. I think if we can we shift to that craft? I'm not sure. There we go, look at that. Okay, this will decay, but we wanted to make sure that this is able to land on its own, because the rocket alone is pretty heavy. So let's go ahead and jump ahead until we hit the atmosphere and see what happens. And so now all we have to do is let this thing orient itself. As it starts to hit the atmosphere, it'll actually naturally point so that the heat shield is facing the atmosphere, which is one of the great things about this design, because we are completely unpowered and kind of at the mercy of the atmosphere. And we got some re-entry effects pretty high up because we are going relatively fast, which means that I started to get a little bit nervous because we were getting a little bit of wobble still, but fortunately we seem to be coming down. And it would have been nice if we could get ourselves into, land on, say, the North Pole or something, but unfortunately it's kind of hard to estimate exactly where we're going to land, because we kind of scripted this without that in mind. So you see me continually checking the heat shield. So it's got an ablator on it, and what that is that it's a material that will sort of ablate away and burn up as we go down in the atmosphere, but it makes sure that the rest of the craft stays cool, which means that we're not going to explode as we come down into the atmosphere, despite my nervous checking and checking and checking. And Valentina is perfectly content to be hurtling through space, well, not even through space, hurtling back toward the planet at ridiculous speeds, but thankfully we are slowing down, and now we've just got to make sure that that parachute will indeed deploy so that we can recover all of this wonderful science. And we've actually, I was hoping that we might land kind of really, really close to the border here, but we ended up just far enough away that it didn't make sense to try and swim over and get a whole bunch of EVA science from the multiple biomes. But we did land, and Valentina could get out and get some additional final science before we recover the craft, which is great, and we can go ahead and jump back and see how much science we got from this mission. And 113 science, mostly from those EVAs, but also a little bit from recovering the craft and being in orbit. So it's time for us to hop over into the tech tree and see what we can get. Okay, so with 113, I guess 0.8 science, we should have enough to unlock the first set of solar panels, which is going to be really important for keeping things powered. There we go, the photovoltaic panels, voltaic. And the one other thing that I want to get is this LV909 engine, but we are just shy of enough science for that. So I have a plan. So Jebediah has gone out in a ship called Science Getter, and we've got duplicate experiments on this, and we are going to get some science from the runway, because all of the areas at Kerbal Space Center, well, most of the areas I should say, you can get science from those. And so the plan here is that we're using these solar panels, and we are going to roll ourselves off the runway and over to the spaceplane hangar and get some additional science. So we'll jump off, we'll do our EVA and grab some science from the runway really quickly, open the materials bay and look at all of that, and check the temperature and all of that sort of stuff. And then there's the mystery goo on the back. And at which point, it is time for us to start rolling our way over. Alrighty, so let's jump back into Code World for a little bit. And the last episode, we wrote this function called tilt. We talked about functions and conditionals and loops, and we're going to be using those in spades today. So we wrote this function called tilt, and it took in two parameters, a minimum altitude and then a new angle. And what it would do is it would wait until our current altitude was greater than that, and then it would go ahead and lock our heading to that new angle. And we had this hard-coded at 0 because we were trying to go into a polar orbit. What I want to do is actually, because there are a couple of problems with this. So one is that we've got this in here, which is means that we can only use this function if we want to go north. The other thing though is that we can't do anything to change the throttle. And the last thing is that what happens if we run out of fuel, if one of our stages expends while we're waiting to hit that minimum altitude. Well, I'll tell you what happens, because I had to tweak the various altitudes that we waited for to make sure that we staged at the right times. It's not fun. So what I've gone ahead and done is written a more complex version, and I've called this execute ascent step. This is going to take 4 parameters. So we're going to take a direction that's northeast, southwest, that sort of thing. We'll take that same minimum altitude and we'll give it a new angle and a new thrust. So the first thing we're going to do is we're going to set the previous thrust to max thrust, and this is a way for us to check whether or not our stage is burnt out. So the max thrust value is if we were firing at full throttle, how much thrust could we get? And so if any one of those engines burns out, that value is going to shrink. Now previously we had done things like check stage liquid fuel is less than 1, then would do something stage actual stage that. But if we've got multiple rockets that are firing at the same time and we only want to ditch a few of them, we may still have some liquid fuel in the current stage, so this wouldn't work. So using this max thrust thing is going to help. So we're going to set the previous thrust to what the max thrust is right now. And now we're going to do this loop called until false. Now this basically means this loop is never, ever, ever going to end. It will, but bear with me. So we're going to go ahead and loop here, and we're going to wait 0.1 seconds between every step of the loop. And then we're going to do 2 things. First, we're going to check if the max thrust, the current max thrust, is less than the previous thrust, and I've added -10 here because occasionally, you might have, max thrust that's 100, and then for some reason it's 99.9, and then we'll get into trouble. So we want to make sure that we've reduced our capable full throttleness by a significant amount, and then we know, okay, hey, we one or more of our engines is burned out, so we probably need to stage here. We're going to set this current throttle to what the throttle is now, just kind of to figure out what we were currently thrusting at, and we'll save that. We'll lock the throttle to 0, we'll wait a second, stage, wait another second, and then throw the throttle back to what the current throttle was before we had staged. And then again, we'll set this previous thrust to the new maximum thrust. So now that we've staged, what is now what we could possibly thrust at if we were at full throttle? So that's going to go ahead and handle the staging. So while we're looping over here, if we detect that we need to stage, it'll go ahead and do that for us. Next, we're going to check that original stuff that we had in our tilt function. We'll say if the altitude is greater than the minimum altitude, we'll lock the steering to heading, and we're going to pass direction and the new angle, not just 0. And then we'll lock the throttle to the new thrust, if the new thrust, because the new thrust is also being passed in. And then we're going to call this thing called break. And what break will do is it will find the loop that you're currently in, and it'll say, okay, we're done with that. So this is really cool because it means we can say something like execute ascent step, and we can say, 90 degrees. So we want to go east, and we'll say at a minimum altitude of 0, then we want to tilt over to 85 degrees, and we want to have the throttle at full. And then we can do another one, execute ascent step at, still at 90 degrees and at a min altitude of 10,000. Now we want to tilt over to 75, and we want to lock the throttle to 0.5. And this will go ahead and execute all of these steps, but it will also make sure that if we happen to require a staging event while we're waiting for those altitudes, it'll go ahead and handle it for us. But I'll tell you that we can actually do something that's even cooler, because we're still going to end up having, a bunch of code, would end up executing all of these various, execute ascent steps. So maybe, we initially were we're waiting till 0, and then we'll say wait until we're 500 meters off the ground, and then lock the throttle down to 0.75, so we're not going too fast when we're in the low parts of the atmosphere. We'd have a 10,000 and a 20,000 and 30,000 and all those sorts of steps. What would be even cooler is if we could just say something like ascent profile, and we'll say set ascent profile to list, and then we could just give it a bunch of values, right? So we'd say at 0, tilt us over to 85 and put the thrust at 1, and at 500, keep us at 85 but set the thrust to 0.75, and at 10,000, now let's start to tilt us over, do something crazy like 30 and lock the throttle to full. And we could indent these to make them a little bit more readable, and I can add altitude and angle and throttle, and let's actually indent these so they sort of match up. That's fine. There we go. So then we would be able to kind of set up, that's closer, right? There we go. So then we'd be able to kind of just set our entire ascent profile and say, just run on that. So I've written this function called execute ascent profile, and this is going to do pretty much what we want to have happen with this set ascent profile to list. We can go ahead and call this saying execute ascent profile, and we'll pass it a direction, and then we could pass it our ascent profile. So this would be how we would call that. So this takes two parameters. It takes that direction, then it takes the profile, and then what we're going to do is we're going to say set step to 0, and then we're going to say until step is greater than or equal to the profile length minus 1. I could probably clean that up. I should probably clean that up. But until this step value is greater than the number of things that we passed in our list, we're going to call that original function execute ascent step, and we'll pass it in that same direction, and we'll say profile step plus 1 and profile step plus 2. So if we imagine this list, right, because this list we've formatted it nicely, but really what it looks like is something like, let's see, 0, 85, 1, 500, 85, 0.75, 1030, 1, right? And that's kind of messy. What we're going to do is we're going to say, as we're stepping through, so we set step to 0. So the first time around, this is going to go ahead and take the first value. We're talking about an index, in our list. So the 0th element, which is the first element in the list, has a value of 0. So it would run with 0. Then we'll say profile step plus 1. So we're going to take the second element, and we'll bring in 85, and then we'll say profile step plus 2, and that's going to bring in 1. Then we'll set step to step plus 3. So the next time that this loop executes, it's going to start at this 500 value here. And then step plus 1 will be 85, and step plus 2 will be 0.75. And so we can use this to pass the arguments to this execute ascent step, and it will go ahead and loop until there's no more data to operate on. So this is a really cool way for us to basically set up our entire script to use these two libraries. We'll just say set our ascent profile to list, and then execute the ascent profile, please. And that's exactly what we ended up doing in our boot script. So let's jump to that. Okay, so here we are in the boot script, and the first thing that I'm going to do is I'm going to check to make sure that we are less than 100 meters off the ground, because the boot script will actually run multiple times. If you were to switch crafts and jump back to it, it's going to try and run that boot script again, and we don't necessarily want that to happen. So what we'll do is we'll copy this exec ascent profile.ks from the archive, which is the file that we were just in, and then we'll go ahead and run it. Now it's not going to actually do anything, but it will set up those functions for us that we wrote. So we'll then say, and we're going to do exactly this, we'll say set ascent profile to list, and we're just going to specify all of these altitudes. At 0, I want you to tilt 80 degrees off the horizon and go full throttle. Then when we hit 2,500 meters, put the thrust down to 0.35, and we'll just keep on doing that, and we'll specify all of these steps of our ascent, and then we can say lock the throttle to 1, wait a second, stage, and then execute the ascent profile, please. And this will get us all the way to space. Now there is some additional code because I didn't want to specify all of this based on strictly altitude. So what we're going to do is we're going to wait. This will get us most of the way to space. What we're going to wait then is until we are close to our apoapsis. We'll lock the throttle to 0.75, and then we are going to burn until our periapsis is almost greater than 70,000. And then we'll lock the throttle to 0, wait in 1, because we want to make sure that we ditch the drive section so that we don't end up with this big honking thing in the middle of space. And we certainly don't want our orbital debris to be, we want to make sure that the orbital debris will fall back into the atmosphere. Then we're going to wait 10 seconds, we'll lock the throttle to 1, and we will wait until our periapsis is above 70,000, which means that we are in orbit. And then finally we're going to toggle the lights and enable our communications. We'll lock the throttle to 0, and we'll lock the pilot main throttle to 0 to make sure that it doesn't start burning when the program shuts down. And that's all that we wrote. And let us launch, and we are off. Now this is, I realized now after the fact that we've gone through this entire video without me explaining what we are actually trying to do. Now this is using the same launch system that we used for our first orbit with Valentina, but this is actually using an unmanned probe at the very top. But one of the things that we're doing is we're setting up this game, in addition to playing with the Kerbal operating system, we're also using remote tech. And what remote tech does is it actually ensures that you must have an active connection to the Space Center if you want to control any of your probes. And so we've got this communitron at the top, and we're using this probe body, and we've got a bunch of batteries and solar panels to make sure that we keep it powered. Yeah, so the idea is that this can act as a relay satellite to vary signal between the Space Center and other ships that we may have in orbit. Now this is using an omnidirectional satellite. There are kind of two kinds of satellites in remote tech. One you kind of have to point in a particular direction, and one is the omnidirectional antenna, and that operates on a shorter range, but we're going to put a bunch of these satellites into orbit. That way we know that kind of wherever you are around Kerbin, we can always get a link up to the current ship. And one of the great things about the remote tech mod is that it also integrates very well with KOS, in that we actually can't access the computer terminal if we do not have a connection. So as we go on, we're going to eventually start writing, kind of more complex scripts, and there is an actual space limit on how much we can actually store on the hard drive. So we're going to have to upload kind of new instructions to things once they're already in orbit. So it's very important that we actually have a satellite network set up so that we can reach these crafts, and hopefully we'll be able to go to the moon and other planets and start gaining science there, so we can advance further in our tech tree. And we see the Ascent profile is working really, really smoothly, and I think we're getting close to being able to ditch this first stage. And we were locking over to 0 degrees, so we're now getting very close to actually orbital velocity. We're picking up. We can see maybe not orbit. We're certainly, we shall go to space today. And there they go, saying goodbye to the side boosters, and now we are just going to go ahead and coast our way up to apoapsis. Now, I actually kind of tweaked the values for this over the live stream that I did on Monday, and it was it's entertaining because you can't actually do much time warping when you're using KOS, that is, because if you do, the script sometimes loses its place. Or if you've got kind of all of these complex steps, if you skip over one, let's say we're waiting for a minimum altitude, or we're waiting till we get close to apoapsis or something like that. If we skip over that condition, it may simply not fire and the program may hang. So we kind of have to run these and let them get most of the way there, and then see, okay, well, did something fail? And if not, we'll go back and start tweaking that Ascent profile. But as we kind of continue on this, we're going to start writing more and more of these sort of helper functions. That way we don't have to start, rewriting everything from scratch every time that we want to launch a new ship into orbit. So hopefully this Ascent profile function is going to be something that we'll be able to use over and over again. And certainly if we're using the same launch vehicle, we should be able to use pretty much the exact same ascent profile, and then we'll just need to, make some additional tweaks whenever we change what we're actually doing to launch. So I'm hoping that we're getting close to apoapsis here, and as soon as that happens, we should start firing now, and we're going to almost circularize. There we go. Because we want to make sure that that drive section actually falls back into the atmosphere and doesn't litter up space and leave some debris for us to collide into at a later point in time. So we're getting there, and our speed is picking up, and we're close. We're getting there. Come on. Get that periapsis up. And then the satellite itself will go ahead and finish up the orbital insertion. So I think we're getting pretty close there. Where periapsis should be peeking out any second now. Come on, there we go. And we've ditched the drive section. And we can let the satellite circularize, and then we can launch a couple more relays and start getting a signal all around Kerbal. But that will have to be in the next episode, so I will hope to see you then. Cheers.